Hello, everyone. Today, we will learn about collecting design data for road subgrade as part of the design and interpretation of subgrade structural drawings. According to the test methods of soils for highway engineering, soils used in Chinese highways are divided into four categories based on the characteristics of particle composition, plasticity index, and organic matter content. Over coarse-grained soil, coarse-grained soil, fine-grained soil, and special soil, further subdivided into 11 categories. Based on the relative content of different size fractions, soils can be classified into over coarse-grained, coarse-grained, and fine-grained soils, with the division boundaries and ranges shown in the table. Soil with an overcoarse fraction mass greater than 50% of the total mass is called over-coarse-grained soil, which can be divided into floaters and cobbles based on the content of boulder particles. Soil with an overcoarse fraction mass less than or equal to 15% of the total, and where the mass of overcoarse and coarse fractions combined is more than 50% of the total soil mass, is called coarse-grained soil. It can also be divided into gravelly soil and sandy soil based on the content of the gravel fraction. Soil with a fine fraction mass greater than 50% of the total mass is called fine-grained soil, and fine-grained soil containing organic matter is known as organic soil. There are also many soils with special properties in nature, such as loess, expansive soil, red clay, and saline soil. These soils with special properties have a significant impact on the quality of subgrade engineering and required targeted treatment. In our industry, there are many technical personnel like academician Huang Xiling, who are silently driving the development of the entire industry. The noble sentiments they exhibit in their work and life represent the tireless pursuit of generations of Chinese scientists toward the country's construction endeavors, embodying an enduring spirit of inquiry. This is our nation's shared wealth and a spiritual legacy for future generations. I hope the future engineers among you will carry forward the legacy of your predecessors, compose the beauty of our generation, remain true to your original aspirations, study diligently, innovate courageously, and take on the historical mission that belongs to us. Let's now look at the engineering properties of different highway subgrade soils. Over coarse-grained soil has high strength and stability and is an excellent material for constructing subgrades. Well-graded gravel mixtures with good compaction density and engineering properties can also be used for intermediate and high-class pavement bases. Sandy soil with no plasticity and strong permeability has good strength and water stability, but it is loose and difficult to compact. Sandy soil containing a certain amount of coarse and fine particles is easily compacted and is an ideal road-building material. Silty soil, containing more silt particles, has slight stickiness when dry, but is easily crushed, generating dust. It quickly becomes soaked and turns into slurry when wet, exhibiting strong capillary action, and must be treated before use. Cohesive soil with significant plasticity and water retention can achieve stability in a filled subgrade when properly compacted at an appropriate moisture content and provided with good drainage. Heavy clay is impervious to water, with high cohesion and plasticity, hard when dry, and difficult to construct. Based on the engineering classification of subgrade soil, it can be graded from 1 to 6, corresponding from loose soil to hard rock. The purpose of grading is mainly for engineering feasibility studies or budget preparation. serving as a basis for evaluating construction difficulty and applying technical methods. That's all for today's class. Thank you.